In this video, we look at collision theory, what it takes to make a reaction actually happen, and the three pieces of collision theory. All right, so collision theory. All right, collision theory basically tells us what needs to happen for a reaction to actually take place, right? If we're out there in the world, chemical reactions aren't just like, boom, happening for no reason. They have to abide by collision theory, okay? Collision theory, if you look it up in the Googles, all right, it says it's the conditions necessary for a chemical reaction to occur, okay? It just means you gotta have these things. You gotta have these things collide. You have to have them collide correctly. Otherwise, there's not gonna be a reaction, okay? And there's three pieces to it. Here we go. Piece number one is called molecular collision. All right? And this is basically the easiest one to understand. All right? This means your reactants must interact for a reaction to happen. AKA they must collide. Okay? This hopefully makes sense intuitively, right? If you had a reaction, you have two reactants that are going to react with each other, but they're on opposite sides of the room, they never touch each other, well, there's no reaction, right? Nothing's going to happen. So in order for a chemical reaction to happen, you actually have to have the two reactants collide. You have to have them interact with each other. Basic, I know, all right, but that's point one of collision theory. Those two things gotta collide, all right? Easy. On to point number two. Activation energy. Probably the trickiest to understand, if I'm being honest with you, all right? And what this says is that in order for a reaction to happen, okay, according to collision theory, you can't just have these molecules bump into each other, okay? They have to bump into each other with some force, all right? In order for a reaction to actually happen, you have to have enough energy when these two things collide to overcome the activation energy to make that reaction happen. Okay, so you're talking like fender bender, boop, nothing happened to your car. You have enough force, you have enough energy, those two things slam into each other, your car's busted, a reaction happened, right? That's what we're talking about with activation energy. So, all right, the particles must have the minimum energy to result in a reaction. That means they have to have the activation energy, which sometimes we abbreviate as AE, capital A, capital E, because we're lazy and that's too many letters, okay? All right, so activation energy, you have to have enough of a force, enough energy to actually have those two things collide and make a reaction happen, okay? And point number three is collision orientation, which is actually, I think, the easiest to understand. Well, I don't know. 1 and 3 are the easy ones. I'm going to be real with you. 2 is the hardest, okay? Collision orientation is that your particles must come together in the correct direction to have a reaction, all right? So collision orientation just means that your particles have to collide actually in the right direction for a reaction to happen, okay? All right, so a good example for this one would be NO2 plus CO react to make NO and CO2, all right? And if I have these little guys out here for you. All right. So I have these lovely molecules that are floating about, okay? And if they collide correctly, then I can get this reaction to happen. So that means if the C and the O, when these guys are moving around, if the C and the O collide, then this oxygen's gonna separate away from my NO2, connect to my carbon monoxide to become carbon dioxide, right? But that's only if I have the proper orientation of the O's and the C's connecting. So they actually have to collide. And they have to collide with enough energy. It can't just be like, bump, I'm done, womp womp. No, it has to be forceful enough to overtake the activation energy so that it actually will take that oxygen away from my nitrogen dioxide, okay? If my nitrogen dioxide collided like this, okay, nothing happens. Even if I have these two molecules randomly out in, out in the space of my room, not my room, in general, okay, and they find each other, boom, they collide, and they collide with enough energy to overtake the activation energy. Still doesn't matter because they're not oriented properly. The nitrogen and the carbon are not going to connect. So they just go away, nothing happens. Okay? If my carbon monoxide was flip-flopped and the oxygen and nitrogen collided, again, not oriented properly. Oxygen and oxygen, nothing happens. Okay? I have to have these two molecules, or, whatever, two compounds, two elements, whatever it is that's reacting. Okay? I have to have them actually find each other in the space that you're working with, in the system. They have to find each other. They have to collide with enough force to overtake the activation energy, and they have to be rotated and oriented properly so that the reaction will actually occur. Not too tricky. Hopefully. Good luck.